Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about electric highway or e-highway. So let's dive right into it. Now, why exactly do we need something this fancy as e-highway? Well, the reality is EV batteries are flat out not good enough for heavy loads. Meaning, are they good enough for cars? Yes. Right now, at this point in time, we have reached a basically good enough point, meaning yeah, people will say, oh, I want 10,000 kilometer range, but does not, you don't really need it. As in, like, if majority of people have been surveyed as in like their cars have been studies, as in like data extracted from Google, is like, yeah, most people don't drive like more than 60-70 kilometer per day, and if your battery has that capacity, it's like, yeah, more than good enough. It's like, it's almost a psychological limit at this point in time. So electric vehicle in terms of cars, done. But the moment you think about trucks, big trucks, 18-wheeler trucks, yeah, good luck. Yeah, that's not happening. And there are other aspects of it. You may think, okay, what if we just add a huge battery? Will it work? In physics, yes, but consequence would be you will sacrifice a very large percentage of your payload capacity simply because there are legal weight restrictions, weight class, as you will say, like commercial vehicle class A, commercial vehicle class B. Yes, you can carry even space shuttle over roads, but again, they require special permit, ludicrously high cost. But for normal truck, like you, any Tom, Dick and Harry can drive, there is some laws, like some serious laws. And in those laws, weight is something taken very seriously. And if you are saying this truck has, like, let's say 15 tons of battery itself, people are like, dude, that means I can only carry, let's say, 10 ton compared to, let's say, normal truck which it can carry 30 tons. Again, just pay attention to the numbers, like the ratios of the number. That will be the consequence. That's why we cannot utilize EV trucks as well as you might think. Bus does not have to suffer too much because humans don't weigh that much, but trucks have to deal with this very seriously. And trucks are the backbone of trade, while railway is the main muscle of our trade. At the end of the day, you still have to utilize truck either from factory to railway station or railway station to your warehouse, and from warehouse to your actual personal delivery. So you get that point. Trucks are backbone technology, meaning it has to work, it has to be reliable. And biggest problem with that is, while diesel engines are awesome for what they do suffer supply issue, meaning your countries, let's say like India, generates more than enough food. Like, we got this food, like we sorted it out. Here's the problem with that: the cost of the food is not fixed by the farmers, it's fixed by the third party, meaning some other country is like deciding what we're gonna charge for fuel today. If they increase the price, a farmer has to pay the truck in order to ship it from point A to point B, and then your food prices goes up simply because somebody else decided. And that's a very serious side effect, that diesel supply is not stable. And let's come to the CO2 emission aspect of it. If you take all the diesel vehicles, their emission versus one huge engine, that would be like, let's say, same power rating, the same power rating one would be much more efficient, one engine would be much more efficient. So consequence of having thousands, as in like thousands of running engines 24/7 into 365, has huge CO2 production and ludicrously high NOx emissions. Now, NOx emission is a toxin, meaning it's not taken lightly. Like CO2 is not gonna poof you out of existence. NOx will do that. It is very toxic and dangerous, meaning it has to be reduced, it has to be managed. So basically creating a scenario where you no longer need diesels at the same amount, basically your diesel dependency goes down. It's really wise. It's not like, oh, it's a green thing. No, it's good for your pocket, it's good for your food, it's good stuff. Basically, there are incentive to do this. It's not like hippy dippy economics things. It's like, yeah, we have to do it so we have stable, reliable economics. So why don't we just electrify roads? Biggest problem is we can't go under the road. We want to go under the road, but we can't go under the road. Now, one thing you have to understand very thoroughly: there are generally 3 layers to a project. And if something you are trying to do, let's say this magical drive, and you're like, hey, physics does not think it can work, just throw it away, don't waste your time on it. Then you have, okay, almost anything can work in physics, but question is, can you actually build it, as in like the engineering layer? That's the 2 layer, physics and engineering. And then we have the god tier layer, meaning the economics. There are many things on this world that should work, have been made, have been produced, but economics didn't support it, and it went poof. For example, Concord. So reality is, don't just go on physics and engineering, because almost anything is possible, including under road system of energy transfer. But economics, most of the time, every time, because these systems are old, as in like 10 years old kind of system, people have tried it. Every time the reality was the same. The economics is simply no go. For example, having a trench which is like completely closed, meaning a tire can drive over it without any damage or risk or going into a ditch. It will have a current collector that will go in the system, and trucks will drive on top of it. Yeah, any Tom, Dick and Harry that works with a tram system is like, yeah, no, you don't do this. This is very problematic, very expensive, and no. people have tried this, Sweden has tried this, it's like outcome is same. And think about this, like they also have to deal with snow. If you're in case of USA, many places they also have to deal with sand, I'm saying salt. So salt, humidity, metal, they don't make love together, they destroy each other. So fundamentally ludicrously expensive to maintain. And this is one thing you always have to understand, it's not the cost per kilometer that is the end game. How much money you have to invest to keep it up, because roads are not what you call oops it went down. Roads are something low, they must work 24/7. So in those sort of scenario, maintenance is very seriously taken. You cannot just say, oh, use this technology, oh yeah, it just requires maintenance every week. They're like, take this shit out, never bring it back again. So it is one thing very serious. Now you may like, how about inductive charging? It's too goddamn inefficient. Every time somebody comes up with us like, wireless car charging, I'm like, thou shall never try to do this because it's wasteful. We have known that we can transfer energy from A to B wirelessly over a century. That's how transformers work. Transformers do not have continuity from primary to secondary. It's literally transferring energy wirelessly. It just have a iron core to make it more efficient. But can you get the same operation without having that core? Yes, that's the whole point of your magnetic key charging. I'm saying key charging. And reality is it's idiotically inefficient, meaning you are wasting energy. And there is a what we call a inverse square law, meaning if your gap between, let's say, receiver coil and transmitter coil is almost touching each other, like your mobile phone and your wireless charging pack, it's let's say 70 to 80% efficient. Like, wait a minute, that's it? Yeah, you already burned through 20 to 30% efficient. Now if you stretch this puppy to, let's say, in the case of car, at least 10 centimeter, at least, yeah, good luck. You're gonna be burning megawatts of energy as waste energy. Let that sink in. That's why nobody does this sort of thing. In paper it sounds awesome. Oh, we're gonna have completely sealed system, no worry about salt and all that, and somehow magically you're gonna assume this thing has same structural rigidity as a basic road. Yeah, good luck with that. And it's gonna be completely enclosed under, and somehow it's not gonna overheat. The waste energy itself will bankrupt a country, because the trucks consume kilowatt hour of power continuously. In those sort of scenario, having like, we are sending, let's say, total fleet load would be, let's say, 5 megawatts. You're like 5 megawatt plus 80% extra energy because of the wastage. Yeah, country will go bankrupt. And electricity is cheap but not free, so you cannot just waste YOLO amounts of it. So that's why every time somebody have tried this sort of system, the outcome is same. You can do this. Physics is not stopping you, engineering is not stopping. There are companies that will sell you products that can do this, but reality is whenever you actually deploy it, your electricity will go YOLO, especially inductive. And if you have like trench system, your maintenance will go YOLO. So that's why we cannot just use this sort of simple things. And whenever you see that, don't get carried away. It's like, oh, there is a like prototype. Yeah, we have had this sort of system for 100 years. It does not work. So what is the solution? Well, solution is low voltage DC. Low voltage in this context translates to anything under 1 kV, meaning around 800 volts. And some systems are like as low as 600 volts. Now you may be like, why this low voltage? Well, reality is railway system runs on very high voltage. For case of India's railway, it's around 25 kV, 25,000 volts. Consequence of that is like whenever some like a metal body, as in like a truck, is going under the railway crossing, it's a very serious risk of arcing. Now again, generally it does not happen, but it is a very serious risk. That's why railway cannot just go, what if we pump the voltage? There is a serious risk of arcing. And if you have roads where you have hundreds of metal trucks, buses and all that jazz, and they are not crossing like, transversely like this, they are crossing parallel to it, yeah, electricity can make love. It can just jump from the conductors to the goddamn object. So you cannot accept that risk around common civilian public. 800 volts, that's like safest accepted system, where it's like, at 800 it should not have. Even on rain is another thing that you have to keep in mind, because while a dry air has very good resistance, wet air does not. It can literally create a short circuit path, so you have to be very mindful of that. It has been tested for around 100 years, so we know for a fact that low voltage DC is safe for public use. Low voltage DC was already used in tram systems. And then you have two pole overhead wire system. Now this is the critical aspect. General normal railway system and light rail metro tram system, they have one, because they have return to ground, as in like earthing directly on the earth. You do not have that when you have rubber wheels. So for this reason, they had to close the loop. It has to have two poles, positive and negative. In DC, it is like positive and negative. And It has been used. It's one of those systems that Soviet Union loved to doing this, and Russia is still using it. And again, they had a really amazing option with this. It's like once they started to mobilize their whole fleet, they realized they found a lot of oil. Now they're like, what if instead of removing all this ecosystem that we have built of trolleybuses, what if we keep using it and sell the oil to other people? That was amazing. That was like a genius move. And many other European countries have also done this. Now you may be like, okay, wait a minute, this sounds like awesome. This sounds like 10 times better than metro system, metro as in trolley system. And why the heck everybody is not using it? Well, while everything about the system is awesome, it's the poles that are the weak link, meaning it requires a really good road, otherwise the pole will literally bounce out. And again, those trolley, because there are tiny wheels in there, it has speed limit, meaning even if your engine, the power supply system, everything can work, this puppy cannot go very fast. Now again, they are designed for stop and go traffic, so it's okay. But if you are traveling over highway, yeah, good luck with that. It reaches very high quality road, and you are just hoping, because the most common issue with this sort of system is that pole snapping off, meaning pole will go twink away from the cable, and that driver have to stop it, come out, put it again, then do that. And that's why the uptime of the systems are very low. But it is a completely tested system, and in some scenario where you have good maintained road, not a hectic weather, and some things are controlled, they do perform good. But that's the only issue, is that poles are not very reliable. But it does work. Every aspect of this puppy works. So what's the solution? Solution is going from that trolley system going to railway system. Now railway system have been tested at much higher speed. Again, we have trains that easily go to 100 kmph like lol, and we have bullet trains that can go like Shinkansen, go up to 350. So we know this. We know how to make a pantograph system that can work at very high speeds. So somebody came up with the idea using that. Same thing, you still have the two system, but you also have two pantograph. And one railway in the world have already tried to do this. I could not figure out how they are doing that, but apparently they had 3-phase transfer to a train. They had two from top, but I could never find where they are transferring the third, but it was a unique system. Only 1 or 2 pieces have ever been made. But this is a very system, positive, negative. You have two current collectors, done. Now the trucks are very complex in this scenario. It's very complex. It has internal combustion engine. Like, wait a minute, it's an electric system. Why they have internal combustion? You have to understand, they are only expecting this to be from highway to highway. Meaning, let's say you have a stretch of highway from point A to point B. The last mile, basically, whenever you are deroading from highway, wherever you are going to your warehouse or your factory, it will not be covered by this system because it's too goddamn expensive. And again, you really don't want that railway system where every kilometer has been mapped out. It's very complex to do. So it's not gonna be like that. So how do they drive that? They will use engine. I'm like, why can't they just use battery? Well, problem is that batteries are same thing, huge, heavy. So even to give a modest amount of range, as in like 50 or 60 kilometers, good luck. But again, you can do that like 10-20 kilometers very easily. So internal combustion engine going to a generator. Now generator has a power electronics coming out of it. That same power electronics will be shared by overhead wire. Then it will go to battery. Battery is there for multiple reasons. First, to improve efficiency, as in like it will also allow regenerative braking. And during off time, you don't have to rely on the basically internal combustion engine. You can use battery itself if the range is not very very far out. You can do that. It has motor drives the drivetrain. Everything works, and it does allow independent scaling, meaning based on the customer requirement, you can change the engine from diesel to CNG. Many European countries are trying to do that, and India already have a very good CNG infrastructure, especially in Delhi. So it can be replaced, like engine can be swapped out. Battery size is dependent on your load. You can figure out, it's like, hey dude, from our requirement point of view, even though let's say it's very far out, we don't need that battery, you will put that. That will reduce your dead weight of your truck. You really want that dead weight to be as low as possible. And it does add a lot of cost, meaning this sort of truck is at least 3 times more expensive. So fleet ownership goes up, meaning whatever country, for example, let's say there is a cement plant and there is a dedicated freight corridor, as in railway link, and they are like, let's say 30 kilometers away. There are situations like this, like right now in India, almost all cement plant have something similar to this. And let's say the highway link from factory to main road to basically railway station, that link of 30 kilometers, let's say 29 kilometers of that is properly electrified. They will utilize this. But in those sort of scenario, the company that is buying the trucks, they have to pay multiple times more for trucks. And on top of that, they have to have faith in the road network, meaning the road is properly maintained, because again, the sole reason railway can do at very high speed because tracks are maintained. Road have to be maintained to very high standards, not god tier standards, because be mindful, all those pantographs are not locked pantograph, they are floating pantograph, meaning they can float. There is a camera that is looking into the cable system and is tracking it. Otherwise it will simply not work, because if driver does even a little bit of steering wheel, your pantograph will fall off. Not fall off as in like disconnect. So for that reason, there is an independent tracking mechanism that solves the issue of trolleybuses where they're like, the cables were like, poing, poing, pulling off. That's not going to happen. So they have to have faith in that government is going to maintain that road, and whoever is the contractor for the overhead wire, they're going to do their job, because if they don't, they will be stuck with, well, utilizing fuel again, and they will have a a truck that costed 3 times more. So it does require a bit of leap of faith. So what we can expect in the future? Well, this right now at this point in time is the easiest way to solve that hyper heavy battery issue. Meaning every Tom, Dick and Harry can design a electric truck, but battery size is like, yep, nope, ton by ton by ton. And not to mention, the heavier the battery becomes, the per kilometer, basically kilowatt consumption per kilometer goes up. So you really don't even want that. That solves that. And it also saves from business point of view, strandation issue, meaning you cannot have a scenario if somebody forgot how to basically charge their system, or let's say the charging station had a malfunction. Let's say it happens, this is a thing, it can break. You had a scenario where over morning they're like, we're gonna drive there, but did not pay attention to how much range they have. And again, electric vehicle ranges are not very reliable right now, so they took off, weather changed, and it's like, yep, now I'm running out of, now it's stranded. You have goods, even if you have to pay extra money, even if you have to take a loss on the delivery, you will still do the delivery, because that uptime is far more important. In many scenarios, the small businesses many times take that serious risk. It's like, no, just deliver the damn thing, even if it costs you more than what is it gonna make on that, because reputation matters. So from a business point of view, if you're gonna say this is an electric bus that hope it works, then no, we want this uptime same as our diesel systems. So it is really good for that, because it's just a hybrid system, whereas if everything works, awesome. If it does not work, we still got this. So that's awesome, and easily become as economical if road networks expand. For example, India is trying to do this sort of system with a very large ambitious goal. Now again, those ambitious goals will not be realized in day one, but somebody have to buy this truck on day one, so they will take a very huge leap of faith and risk. But assuming, let's say it works out, so let's say Delhi to Jaipur, these are the two places, Delhi to Jaipur, and they have let's say 300-kilometer link where it's supposed to be electrified, but let's say in the phase 1 it only 50 kilometer was electrified. Again, saving, if you're especially turning a very heavy load, driving on electricity for at least 50 kilometers, that's gonna save a lot of money. You can start with that. But let's say it started becoming successful, the network became 300 kilometers, awesome, your profit will go through the roof. So it does have that advantage, where it's early investor does not mean you are stuck with the system. It's as the road network will grow, your profit will grow too with it. And it can be done with today's technology, meaning there are many, as in from USA to basically many European places, more than enough real world demo, as in real world people utilizing in real world life from past 5 years have been testing the system out. So it does work from a hardware point of view, from a technology point of view. It's sorted, we got this, we know how to do this, done. This part is sorted. And India is also trying to do multiple road links for multiple places. However, at this point in time, the economics is still not tested, because I did specify that fuel prices are rising, but they don't always rise, and many times they also fall. For example, during basically oil embargo of basically 70s, I think USA was pouring boatload of money into hydrogen, algae biofuel, and a lot of other technology, advanced technology, which they abandoned simply because fuel prices went too down. And same thing can happen right now. Every country, every fleet owner is pouring boatload of money, assuming the fuel prices will always go up. But if it goes down, even temporarily, they will lose boatload of money. In those sort of scenarios, this sort of system is a long-term gamble. If it pays off, you have to be patient with it in long term. Uptime is a very critical aspect, because even in a railway network, those railway line does require serious maintenance. It's not just, oh lol, I put it there and forget about it. It's something that has to be maintained very rigorously, and that also eats up on your cost. So that has to be managed. Fuel cost is another X variable. Road quality, because again, yes, you can drive at 150 kmph, but what if the road is not that good? That is another issue. Equipment lifespan. Now this is a very serious issue for Gen 1 products, because generally all Gen 1 products are garbage. And again, it's not a fault of the system, it's the fault of the fact that we don't know the future. You build the system, it breaks, then you learn why did it break, then you improve it. Same happened with solar panels, because the early solar panels they were flat out not good. Flat out, they were not good. And again, it was not some malice or like, low quality manufacturing. It was like nobody knew how to make high quality ones. And you are asking something that is directly facing sun, like every day from morning to night, is gonna be cooked. So the fact that we have modern solar panels that have been working for past 10 years without any degradation of power, again, some degradation is there, but it's more than good enough. It's like, damn. Same will happen with this thing, but assuming it pulls through, the phase one products must be good enough. They cannot be like, it flat out does not work. It has to be good enough. And then return on investment. Now, assuming lifespan of these sort of truck fleets are, let's say, 15 years, it must do return on investment around 7 to 6 years. It cannot be like, because again, they are much more expensive. So these are the things that have to be sorted. Not the technology. We got the technology. Every Tom, Dick and Harry got the technology. There are like multiple companies that's like, you can just pick up a phone. Hey, Siemens, I want like $500. Siemens is like, this is the payment address and will deliver you. 24-hour Amazon delivery. So we got the technology now, but it's just the economics of it and deployment of it that will determine whether it will become successful or poof. So it was my presentation on eHighway. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you are free. And as always, thanks for watching.